Hey YouTube, what's up? Dr. T here, and welcome to the Altcoin Express and my hometown of St. Petersburg, Florida.
So, in this section, we will deal with all things pertaining to artificial intelligence, otherwise known as AI.
So, moving on to more interesting adventures. Here is the original grid world, and I wanted to do something a little different. And we now have sensor world built, and I wanted to have a robot that could move around smoothly. So that was developed, and it was enabled in a offshoot algorithm to find out how to do that. So this has been developed as the robot, which will be moving around smoothly on the environment. And the new world is now completed. It has two lists to contain the optimum pathway data and the non-optimum pathway data, and then the rest of the framework is built from the frame of the world, specials, walls, horizontal lines, vertical lines, and wall lines, and value states. Take that up a bit, which we'll see on the next, and non-value states. And it can be clipped a little bit, but so this is sensor world. Explain what this is. We're moving up to doing what is essentially deep reinforcement learning. In this case, it's going to relate to deep Q learning. And the difference between that and Q learning is we're going to be using neural networks to enable us to control a larger data set and have that work out where the agent should go and where its data will be dispersed. In order to do that, we need to know what the optimum route is, because we have to obtain the optimum value for each of the states. Now, these are the states as numbered on the grid. Firstly, this is the start state. That's the terminal state. That's the when you actually get to your reward. And the shortest route, as marked by the original set of numbers, gets us there. And based on what was convenient, the optimal pathways are just numbered appropriately and conveniently for putting data onto this pathway and coming down through here where all the numbers are going to be displayed. Now, the importance of being able to do a neural network is that we have to have data. So we have to have a data point for each of these states, which we get from recursively calculating what that data will be. So we're starting off here with 100, and at every time step or every step backwards recursively, that will be decreased by 90%, 0.9%, beg your pardon. So the numbers need to be put around the grid as such. Then the spin-offs need to be calculated based on regressions from this number and regressions from this number, and so on and so forth around here. So that brings us to the next part of this little adventure, and that is what's called V star, which is the optimum values that you can obtain if you the values of the reward back through the grid. So these have been calculated and dispersed through the grid so that they are timely going away, and this is the values on the grid that enable it to come into balance. From this, one actually you get the optimum policy by taking the action which gives you the maximum cumulative reward. So these will obviously variously see transitions. In here there's a transition whereby this is the optimal pathway, and from this point on this is the optimal pathway, and this is the optimal pathway up here, this is the optimal pathway down here, and then this will just branch off down in various places. So that is basically what sensor world is, And now we can move on to putting the agent on here, and then we'll take up the data from grid world and start working, getting the agent to move around here randomly, and that will be the next part of this adventure for me to work out.